Hi everyone, I'm Ali Zanuri, and today I'm going to talk about the study on traffic management during natural disaster in Prince George City, which is my title for doing the PhD dissertation. As possibly some of you remember from the previous semester, I was planning to study on effects of self-shrinking geosynthetic on soil and granular material pre-stressing, but due to some reasons, we were forced to change the topic to study on traffic management during natural disasters, which is obviously another topic. That's the first week that I'm working on this new topic. But today I'm going to present why I'm doing this research and what am I going to change in the city and how I will do it in my research. First, I will talk about the research objectives, and then I will talk about emergency management, and after that, traffic modeling. Uh, in emergency management, we should talk about some steps in emergency management as well as resiliency, the thing that we are and our team is going to increase in the city, and the traffic modeling, microscopic traffic simulation, and the research methodology based on the traffic modeling. Main objective of the research would be increase the resiliency of the Prince George City against the natural disasters of flood and wildfires through increasing the road network resiliency. And it would be improvement of performance for road network for evacuation, for relief and rescue, for recovery, and evaluation of the scenarios for EOP, emergency operation plans, as well as the preparation of the basis for future EOPs. It would be a model that you can test all EOPs in the future. Based on FEMA, Federal Emergency Management Agency, four steps can be defined as steps of the emergency management: the mitigation, the preparedness, the response, as well as the recovery. What is the mitigation? The mitigation is actions taken to prevent or reduce the causes, impacts, and the consequences of disaster. Some of the disaster cannot be prevented during mitigation phase, and in preparedness we should be prepared for these kind of disasters. We should plan and we should have some trainings and educational activities for the events that cannot be mitigated during the previous phase and during the response phase that immediately start aftermath of the disaster. uh, the teams, the response teams, you have heard of response teams, which are the response teams, the fire department, the actually ambulances, the actually Red Cross and other emergency response teams come to the action, and they try their best to reduce the negative effects of the disasters. And during the recovery, we will have the restoration, and we will try our best to increase the performance of the system, the city, or other thing that we are doing the research. Actually, for having a good example, possibly it is a small example, but for making clear, I selected the small example. You can actually generalize it to the city or a larger scale of the state or even a country. Uh, what would be a mitigation phase, for example, for risk of the or for hazard of the fire in a house? We will try our best to adhere to the standards in order to prevent the fire in house. But we will keep the extinguisher in house and we will learn how to use it. It is the preparedness phase. And what would be the response phase? Yes. If fire happens, we will use the extinguisher. And what would be the recovery? if we could extinguish the fire, we will paint or even rebuild the house. These are the phases of the emergency management in a house. You can generalize it to the state or a city or a country even. We will be mostly here in preparedness, response, and recovery. And what is the resiliency? Imagine this is the uh, actually this is the performance of the system. I mean the normal axis, and this is the time. In preparedness phase, we will be here, and immediately after natural disaster happened, the performance drop will start, and we will try our best to decrease the performance drop. We will be here in response phase, and after that in recovery phase, immediately after finishing the job by fire department, the Red Cross and so on, we will try to increase the performance again to what it was before. But even if we are doing good, we can even increase the performance of the system. And if we are not doing good, we cannot increase the system and reach the performance that we had before the crisis. But what would be the resilience? Actually, the resilience would be a resilience or resiliency would be the surface under this graph that we can define it by this integral T0 to TR would be response and recovery. But our research wouldn't just limit it to the resilience, but it covers the preparedness as well. How we can do it? Types of the traffic analysis tools are really a wide range of tools, but the microscopic simulation models are the most accurate, but the most expensive ones. I mean, expensive because it needs lots of data, and the software is really expensive. But the Aimsun company gave us the license for doing our research, so we selected the Aimsun. Microscopic traffic simulation is giving each single agent in the network the behavior, simulating each single cars of the network in the actually city and in the transportation network. It would be based on car following models, microscopic lane changing models, and microscopic gap acceptance models that we will discuss about it in my next presentation. But the research plan would be microscopic simulation model preparation based on the data we gather from the city, and we can put the actually effects of the hazards in the model as well as the scenarios. After completion of this microsimulation model, we can evaluate the effect of application of each scenario and improve the actually scenarios to reach higher resiliency in the city. But the very important challenge we will have is the question which asks, does the model simulate the reality? There is a famous saying by George Box which says all the models are wrong, but some are useful. We try our best to calibrate the model if it doesn't simulate the reality, and after that verification, and we will do the cycle until we can reach the reality. First step would be literature review and data collection. Second would be model development and data completion, and we will complete the data and collect some of the data again. Model calibration, model verification, as well as design of scenarios would be third step, and analysis on model outputs, model runs, and actually redesign of the scenarios, and experimental design would be fourth step. And in fifth step, we will write the dissertation, prepare the paper and publish it, and we will defend the job. These are the actual references we used for preparing this presentation. Thank you very much, and remember, the right question is usually more important than the right answer. Thank you.